Hello students, once again welcome to Bholanath Academy. In this video students, we are going to see the preparation of amine. In last video students, we have seen the first preparation of amines with alkyl halide as a raw material. Now here students, we are going to prepare the amines by reduction of nitro compounds. If nitro compounds are given to you, how you will convert nitro compounds into amines, that we are going to see here. So nitro compounds students, if given to you, you have to reduce it. That is why it is called as reduction of nitro compounds. Okay students, if you reduce the nitro compound, then only it will convert into primary amines. So students, now we are going to prepare the amines, that is second preparation, that is called as reduction of nitro compounds. So here students, nitro compounds are two types of students. Sometimes it is aliphatic and sometimes it is aromatic nitro compounds. So students, aliphatic and aromatic nitro compounds can be reduced to primary amines. Students, mind well, we will going to prepare primary amines by using the metal acid mixture. So students, we are going to use the metal acid mixture as which gives you nascent hydrogen. This hydrogen combines with the nitro compounds and it is reduced to amines. So students, how you are going to prepare nascent hydrogen? Students, nascent hydrogens are very important. So students, if you add stannous, that is tin students, inside HCl, they will provide you nascent hydrogen. So stannous in contact with HCl. Okay students, or if you don't have stannous students, you can add iron in HCl, they will gives you nascent hydrogen. Or you can add zinc metal inside the HCl, you will get nascent hydrogen. Or students, you can use the catalytic hydrogenation. Okay students, so when hydrogen gas is in contact with nickel metal, they will gives you nascent hydrogen. Or students, when you pass the hydrogen gas, these are the molecule, when they will in contact with platinum or palladium, they will provide you nascent hydrogen. So students, or you can use lithium aluminum hydride in ether, they will also gives you nascent hydrogen. Okay students, so nascent hydrogens are very important students. So here we are talking about aliphatic and aromatic nitro compounds. So students, in general students, aliphatic nitro compounds we are writing like this: aliphatic, that we are representing with alkyl group, and aromatic, that we are going to show with minus AR. So students, nitro compounds that we are going to take here is aliphatic nitro compound, that is called as alkyl is attached to nitrogen of this nitro group. So this is called as aliphatic nitro compounds. Now what happens students, they will combine with 6 nascent hydrogen students. We are writing like this students, inside the box we are putting the hydrogen. They are very reactive hydrogen students. Now how you have got this nascent hydrogen students? So this nascent hydrogen you can got from this metal acid mixture. This is first one is metal and second is what, acid. So here students, you can add stannous in contact with HCl, they will gives you nascent hydrogen. Or you can say iron in contact with HCl, they will gives you nascent hydrogen. Zinc in contact with HCl, they will gives you nascent hydrogen. Okay students, or you can use hydrogen gas when in contact with nickel metal, they will gives you nascent hydrogen. This is hydrogen molecule students. This when it will in contact with nickel metal, so they will provide you nascent hydrogen, that is called as catalytic hydrogenation. Platinum, or it may be what, palladium. And here students, you have lithium aluminum hydride in contact with ether solvent, so they will gives you nascent hydrogen. Now here students, if you want to reduce nitro compound students, here 6 nascent hydrogens are required. So what happens students, 6 hydrogen, if you want to remove 2 oxygen atom students, you have to required 4 nascent hydrogen. Okay students, so as a water you are going to remove. So removal of oxygen is called as reduction. Here we are removing the oxygen of the nitro group students with the help of 4. Out of 6 we are going to remove 4, so only 2 hydrogen is remaining. Now they will combine with nitrogen and gives you primary amines. Okay students, so this is your primary amines. Okay students, similarly students, if you are taking aromatic nitro compounds students, aromatic nitro compounds, these are same students, and here you are getting aromatic amines, that is primary amines, but it is aromatic type of amines. This is also first degree amines students. Okay students, along with water. So this way students, whether it is aliphatic or it is aromatic nitro compounds, you can convert into primary amines. We are going to see some example. Here students, I am using aliphatic nitro compounds. For example, if you have taken nitroethane, C2H5, this is one of the hydrogen of ethane. Now you are going to replace with nitro group, so this is called as nitroethane. Now what happens students, when it will combine with 6 nascent hydrogen students, on how it is coming students, when metal, here I have taken metal stainless in contact with HCl. So metal acid mixture, this metal acid mixture will give you nascent hydrogen. Out of 6 nascent hydrogen students, 4 nascent hydrogen are going to remove the oxygen of this nitro. So as a water. So here students, H2O. But here students, this water is having only 1 oxygen atom, but here you have 2. So here 2 molecules of water will be removed. Now out of 6 nascent hydrogen students, 4 nascent hydrogens are required to make 2 molecule of water. Now only 2 nascent hydrogens are now remaining here students. Now it will combines with the nitrogen and it will gives you primary amine as a ethanamine, NH2. So here students, there is a removal of oxygen and addition of hydrogen, that is called as reduction reaction is going on students. Understand students? So this is the reduction students, and students you have to heat it also, then only they will gives you nascent hydrogen. This is the ethanamine, or you can say ethylamine. Okay students, similarly students, you can take aromatic nitro compounds. Say for example students, suppose you are taking, this is first example and this is second example students. Now here I am taking aromatic nitro compound, that is nitrobenzene. This is nitrobenzene students. Now it will combines with 6 hydrogen atom students, from where this 6 hydrogen atom is coming students, when stainless in contact with HCl, concentrated HCl students, you heat it, you will get nascent hydrogen. When these nascent hydrogen students will combines with nitrobenzene, it will remove the water molecules. Okay students, so out of 6 students nascent hydrogen, 4 nascent hydrogens is able to remove the 2 oxygen atom from the nitrobenzene as a water. Now what happens students, out of 6 students, 2 hydrogen, nascent hydrogen, now it will combines with the nitrogen of this nitrobenzene and it will gives you compound is called as aniline, first degree amine, that is aniline. This is the aniline students, first degree amine. Okay students, so this way students, we have taken the example of both aromatic as well as what, aliphatic nitro compounds. Preparation that we are going to see here is students, that is called as reduction of alkyl cyanide. Alkyl stands for R, and cyanide we are writing here carbon with triple bond with nitrogen. This is alkyl cyanide, or we can also say alkane nitriles. Alkyl cyanide is also called as alkane nitriles. Now students, primary amines, here also we are going to prepare primary amines. Primary amines can be obtained by reduction of alkyl cyanide. We are going to reduce the alkyl cyanide with sodium and ethanol. When you add metal sodium in ethanol, it will gives you nascent hydrogen, and this nascent hydrogen will reduce the alkyl cyanide. This is called as Mendes reduction. Understand students, when you are using alcohol and sodium as a metal, then the reduction of alkyl cyanide is called as Mendes reduction. This was done by Mendes scientists. That is why this reaction is called as Mendes reduction. The reaction is very, very important students. The reaction is very exhaustive. So that is why you have to take the precautions, because here the ethanol is very, very, very flammable solvent. Now this is known as Mendes reaction. The reaction can also be brought about if you don't have sodium and ethanol, because they are very flammable. Ethanol is, it will catch the fire. So what happens students, you can use lithium aluminum hydride. Okay students, so but here students, we are preparing primary amines from alkyl cyanide. Cyanide is very, very poisonous students, so here we have added alkyl cyanide. We are going to reduce into primary amines. That is why this reaction is very, very famous, Mendes reduction. In examination sometimes they may ask what is Mendes reduction, so you should know the raw material is what, alkyl cyanide. We are going to reduce alkyl cyanide. Okay students, reduction of alkyl cyanide is very, very difficult method that was done by Mendes scientists. That is why it is called as Mendes reduction also. So students, alkyl cyanide handling is very, very important students, because it is very poisonous. First, whether it is aromatic alkyl cyanide or it is aryl cyanide, both we are going to, they have done the reduction. So here students, alkyl cyanide students, in general you can write. So students, alkyl cyanide, that is R, carbon with triple bond with nitrogen. This is alkyl cyanide students. If you want to reduce this cyanide students, you have to require 4 nascent hydrogen. Only 4 nascent hydrogen is enough. Now from where you are getting this nascent hydrogen students? So for that students, you can add sodium into ethanol, C2H5OH. This is alcohol students. You will get nascent hydrogen, or if you can use lithium aluminum hydride in ether students, they will also gives you nascent hydrogen. Okay students, now what happens students, here students, alkyl will be as it is. carbon and nitrogen there's triple bond. Now it is going to form single bond. Okay students, this is formation of single bond is very important students. With the help of this nascent hydrogen, this carbon and nitrogen second triple bond will convert carbon nitrogen single bond. Now what happens students, out of 4 nascent hydrogen, 2 hydrogen will combine here and 2 hydrogen will combine at nitrogen side, and it will form first degree amines, that is called as primary amines are formed. Okay students, so this is first degree amines students. 4 hydrogen is added, there is no raw material students because all 4 hydrogen is added, understanding? So here students, these 2 reactant will combine and they will form only one product, that is primary amines, understanding students? So here because there is no oxygen, so there is no removal of water, all that. So students, only 4 hydrogen, all hydrogen will added, we can say addition of hydrogen, understanding students? So you will get the primary amines. Okay students, suppose students this is alkyl cyanide, you can also use aryl cyanide also. Here students you can use Ar, carbon with triple bond with nitrogen. This is aryl cyanide. This aryl cyanide students when combines with 4 nascent hydrogen, instead of this you can use, they will reduce and they will form first degree amines. The same way they will combine and they will form the primary amines, that is aromatic amines you are getting. Here you are getting aliphatic and here you are getting aromatic amines, understanding students? This is also first degree amines but it is aromatic in nature. So this way students we have done the reduction of alkyl cyanide in general. Now students we are going to see some example. If you have C2H5, this is alkyl students connected to the cyanide, so we can say ethyl cyanide, or you can say because it is containing 3 carbon, 2 carbon here, 1 carbon here, that is why it is also called as propane nitrile. Okay students, you can say ethyl cyanide or you can say propane nitrile. So students, prop stands for 3 carbon and nitrile is nothing but carbon nitrogen triple bond. So ethyl cyanide is nothing but prop nitrile. When you pass 4 nascent hydrogen, only 4 nascent hydrogen is recorded students. This nascent hydrogen is coming when sodium in added to ethanol. Okay students, so what happens students, this 4 hydrogen will combine, this carbon triple bond will become single bond. Okay students, now out of 4, 2 hydrogen will combine with nitrogen and form amine, and this 2 hydrogen will combine with this carbon, and your this alkyl will be as it is. So this way students you have got total how many carbon, 3 carbon, so you will get propyl amine, you are getting normal propyl amine. Okay students, so this is also first degree amines. Okay students, this is also first degree amines. So here we students I have taken the alkyl cyanide that we have converted into alkyl amine. Now students, suppose you have aromatic cyanide, say for example phenyl acetonitrile. This is phenyl students, CH2, when it is in contact with cyanide, so this is called as phenyl, this is phenyl and this is acetonitrile. This is aromatic cyanide students, when if you want to reduce 4 nascent hydrogen is required, it is coming from when you add sodium metal in ethanol, they will gives you nascent hydrogen. What happens students, here also carbon triple bond is going to be convert carbon single bond, and here hydrogen will combine like this. Okay students, so this is converted like this, and what happens students, this phenyl will be like this, CH2. Okay students, so this way students you have converted beta phenyl as ethylamine, beta phenyl, this is alpha, this is beta carbon, so it is name will be beta phenyl ethylamine. So this way students we have taken the example of both aromatic as well as what aliphatic, we have converted into first degree amines, that is primary amine. This is also primary amines, but it is aromatic type of primary amines, it is aliphatic primary amines. We are going to see the fourth preparation, that is called as by reduction of amides. If amides are given students, how you are going to convert into amines? Here also students, all amides now we are going to prepare into primary amines. Primary amines having same number of carbon atom can be obtained by reduction of amide by lithium aluminum hydride in ether, or sodium in contact with ethanol. Sodium when you add in alcohol students, they will gives you nascent hydrogen. So here students, if you have any amides, that you can convert into primary amines. Okay students, the same number of carbon atoms, the amide is having same number of amines, will also having the same number of carbon. Okay students, say for example students, whether it is aromatic amide or aliphatic amide, both we can convert into primary amines. So example students, you can say in general, if you have any amide students, say for example like this is amide, this is carbonyl group when one valency by alkyl, other is by amine, it is called as what? Amides. This is amide students. When it is in contact with nascent hydrogen, this nascent hydrogen is coming from lithium aluminum hydride in contact with ether, or students sodium metal. When you add in ethanol, they will gives you nascent hydrogen. So what happens students, here also students, this 4 hydrogen, if you want to remove 1 oxygen students, 2 hydrogen, nascent hydrogen is required, they will remove as a water molecules. So there is a removal of oxygen from this amide. That is why it is called as reduction of amides. We are going to remove the oxygen of this amide, so that is why it is called as reduction of amides students. So what happens students, out of 4 nascent hydrogen, 2 nascent hydrogen will combine with this oxygen of this carbonyl and they will remove as a water molecules. Now what happens students, remaining 2 nascent hydrogen now combines with this carbon. Okay students, so this alkyl will be as it is and they will form the primary amines like this. Okay students, this is first degree amines. So here students I have taken aliphatic amide. Same way students you can also use as a aromatic amide. Taking raw material as aromatic amide, you will get aromatic primary amines. Say for example students, this is carbonyl, one valency by NH2, other by alkyl group. So amide students, we are going to take the example. Here students we are going to take, this is the carbonyl students, this is NH2, and here I am going to take as a methyl. So this is called as acetamide. Now this is the raw material students. Now we are going to convert into primary amines. Okay students, here students CS3 carbonyl and here NH2. Now when it is combined with 4 nascent hydrogen students, these nascent hydrogens are coming from lithium aluminum hydride in contact with ether, or you can add sodium in ethanol. So what happens students, this oxygen now combines with 2 nascent hydrogen students, 2 nascent hydrogen from 4 nascent hydrogen. Now it will remove as a water molecule. Now 2 nascent hydrogen now combines with this carbon and it will form CH2 and NH2. Okay students, here the 2 carbon, here also it is what, 2 carbon, first degree amines. Okay students, so here students acetamide is going to be converted into ethylamine. Acetamide is having 2 carbon and here ethylamine is having same carbon. So that is why it is called as what, same number of carbon atom primary amines are formed from acetamide. Now students we are going to see the 5th preparation of primary amines students from Gabriel Phthalimide synthesis. In board examinations sometimes they may ask students what is Gabriel Phthalimide synthesis. So this way students you have to represent the answer. Phthalimide, here students pH will be the silence, we call as phthalimide. Phthalimide is reacted with alcoholic KOH to form potassium phthalimide. So students we have phthalimide is reacted with alcoholic KOH, it will give you salt of potassium phthalimide. For further, this potassium phthalimide is treated with ethyl iodide. The product will be N-ethyl phthalimide, that is hydrolyzed with aqueous NaOH. When it is hydrolyzed with aqueous NaOH and it is forming ethyl amine. Formation of this ethyl amine from phthalimide is called as Gabriel Phthalimide synthesis. This was discovered by Gabriel scientist, and by using phthalimide, that is why it is the name is of this reaction, this synthesis is called as Gabriel Phthalimide synthesis. We are going to synthesize ethylamine. Okay students, that is primary amines we are preparing students. Only the alkyl amine we are preparing. We cannot prepare the aryl amines. That is why this name is very famous students, Gabriel Phthalimide synthesis. Now what happens students in Gabriel Phthalimide synthesis? So students it is required in 3 processes. The first process students we have to use phthalimide. So this is the phthalimide students, benzene ring connected to amide. Now this phthalimide is reacted with alcoholic KOH. So what happens students, this hydrogen now combines with OH of this KOH and they will remove the water molecules, and this K now it will join with this nitrogen. So in second process there is a formation of salt students. Now it is going to combine with potassium salt. Potassium is always positive, so it will be negative students. So here you are getting students salt. Now what happens students, this salt now again combines with, we are going to combine with alkyl halide, any alkyl halide, if you are taking any alkyl halide, so what happens when this is negative charge, now it will combines with positive charge of potassium and it will remove the potassium halide as like this. Now what happens when this alkyl will now it is joined and it will gives you N-alkyl phthalimide. So students, this alkyl is now in contact with this nitrogen and it will gives you N-alkyl. It is this alkyl is attached to this nitrogen, so we call as N-alkyl phthalimide. Now what happens when to this N-alkyl phthalimide, if you add aqueous NaOH, so 2 molecule aqueous NaOH now combines with this N-alkyl phthalimide and it will gives you, so this part of NaOH now combines with this bond will break students. Now this part will combines and it will gives you salt, sodium salt of phthalimide. This hydrogen, 2 hydrogen now combines with this alkyl and it will gives you alkyl amine. It will gives you alkyl amine. This is very important. That is primary amine students. This formation, this synthesis of primary amines, only the primary amines containing alkyl group we can form. That is why this reaction is very important. So this way students, we have prepared the primary amines from phthalimide. The preparation of these primary amines, and this is sodium salt students. Again you are getting salt. So but we have synthesized the primary amines. The formation of synthesis of these primary amines, only the alkyl amine we can prepare. This is only the alkyl amine. Alkyl amines we have prepared students. So only alkyl amines we can prepare from this method. That is why this method is very famous. And that is why it is called as Gabriel phthalimide synthesis students. So this way students we can prepare primary amines. So it is totally dependent on this alkyl halide. If you take the ethyl halide, you will get ethyl amine. If you are taking methyl halide, so you are getting methyl amine. Understanding students? So this way students, this is very important students. Your first reactant is phthalimide and second reactant totally depends upon the alkyl halide. Which alkyl halide you are taking, say amount of alkyl for primary amines you will get. Example students, when it is going to react with alcoholic KOH. So what happens students, this OH of this KOH now combines with hydrogen of this phthalimide and remove as a water molecules. Now what happens students, this K is positive charge, now it will combines with this and it is forming, this is first reaction and this is second. There is a formation of salt, potassium salt students. Now what happens students, this is the salt, potassium salt of phthalimide students. Now what happens students, again students you have to add C2H5 sodium iodide. What happens students, this potassium combines with this iodine and it will remove as a Ki. Now this ethyl, now it is combined with this nitrogen. In third reaction students, there is a formation of N-ethyl phthalimide. This is N-ethyl. Here students, instead of alkyl we have written C2H5. N-ethyl phthalimide. Now what happens students, you have to add aqueous NaOH. So here students, 2 molecules of aqueous NaOH. Now these two will combine sodium iodide oxide and it will form the salt. Here this bond will break students. Okay students, this is carbon and this is hydrogen. So what happens students, it will form the sodium salt of phthalimide, sodium phthalate. This is sodium phthalate students. And what happens students, this hydrogen now combines with ethyl and nitrogen and it will form C2H5 will be as it is, and there is a formation of ethyl amine. This is ethyl amine. This is also a first degree amines. So this way students, we have prepared the primary amines using phthalimide and ethyl iodide. We have got ethyl amine students. So only the alkyl amine we can prepare from this method students. That is why this reaction is very important. In examination sometime they may ask what is Gabriel phthalimide, prepare ethyl amine with the help of the Gabriel phthalimide reaction. So this way students, you have to start the answer by Hofmann degradation, or you can say Hofmann rearrangement, or you can say Hofmann bromide degradation of, or you can also call as Hofmann hypobromite degradation. Here the degradation word is very important students. So amide is given to you, we are going to degrade the amines. Understanding, that is why, and scientist who has done this, that his name is Hofmann. So the word is Hofmann degradation, or you can say Hofmann rearrangement, you can say Hofmann bromide degradation, because here we are using bromine gas, that is why with the help of the bromine we are going to degrade the amide. That is why it is called as Hofmann Bromide degradation, Hofmann hypobromite degradation. So here students, what will happening in the amide students, there is a conversion of amide into the amines in the presence of bromine. That is why it is also called as Hofmann Bromide degradation. And alkali is known as Hofmann degradation of amide. So what is the Hofmann degradation? The conversion of amine into amines in presence of bromine and alkali is known as Hofmann degradation of amide. What is happening students? Amines form with one carbon less. What is the importance students of because of the degradation? What is happening students? There is a one carbon less than amide. If amide is having 2 in number of carbons, so amine will have only 1. Understanding students? So it will have only one carbon always less. There is a minus of 1 carbon. Okay students? So this way students, amines form with 1 carbon less than amide. There is a molecular rearrangement involves the migration of alkyl or aryl group from the carbonyl carbon to the adjacent nitrogen carbon. Okay students? The alkyl group which is attached to the carbonyl carbon students, this is carbonyl carbon, it will migrate and adjust to the nitrogen atom. That is why it is also called as rearrangement, Hofmann rearrangement reaction. Generally students, we can write here, this is the carbonyl, one valency by alkyl, other by NH2. So this is the alkyl amide students. Amide, you are passing bromine gas in presence of aqueous KOH. So here students, 4 molecule of KOH is required. KOH is aqueous. Now what happens students when you heat this mixture? So students, this carbonyl, it will break. That is why we call as degradation. Okay students, this is the amide students. Any amide students, what will happen students when you pass bromine gas and aqueous KOH? So there is a degradation will take place students. So this carbonyl will break, and now this carbonyl will combines with potassium, and it will gives you K2CO3. Okay students, out of 4 now 2 have used students. So other 2 potassium now combines with bromine and it will gives you 2 KBr, potassium bromide. Now here 2 hydro oxygen are there students, they will remove as it water molecules, 2 water molecule we are getting. Okay students, now what happens students, this alkyl will migrate and it will combines with the nitrogen. The alkyl now it will migrate and it will combines with nitrogen and it will form the primary amines. So this way students, you have got the primary amines, formation of primary amines. That is why it is also called as Hofmann rearrangement. This alkyl will migrate and it will combine with this nitrogen. It will form the primary amines. There is a formation of primary amines students. That is, and this will have, because this carbon is removed as a carbonate, potassium carbonate, so there will be less carbon. It is having 1 carbon less, 1 carbon less, 1 carbon less. Understanding students? Because of this degradation. So that is why this is very important reaction students. Now we will see some example. Instead of these students, you can take aromatic amide also. So you will get aromatic primary amines. Understanding? Carbonyl, 1 valency by, here I am taking methyl. Example students. Now what happens students? This is the acetamide. What happens students when you pass the bromine gas, which is very reactive in presence of aqueous KOH? Aqueous KOH. Now what happens students? What will happen when you heat it, this mixture? So students, I have told there is a degradation. So this bond will break. Okay students, now this methyl will, now it is combined with nitrogen and it will form the methylamine. Okay students, so this way students, there is a formation of methylamine. There is a formation of methylamine. This methyl, carbon of this methyl, now it will join to the nitrogen and it will form methylamine, and along with this methylamine you are getting this carbonyl, which is degraded from here students. Now it will combine with KO, potassium of this potassium hydroxide, and you can remove as a potassium carbonate. 2 potassium now combines with 2 bromine and it is removed as a KBr, potassium bromide. Now what happens students, here 2 oxygen will be removed as a water molecules, 2 water molecule will be eliminated. So this way students, we have prepared the primary amines. We have prepared primary amines from acetamide. So acetamide is converted into primary amines. This is very important reaction in board examination. Sometimes they may ask action of bromine and aqueous KOH on acetamide. So this way students, you have to represent the answer. This is very important students. Here it is containing 2 carbon. This acetamide is having 2 carbon, but here methylamine is having only 1 carbon. Okay students, so 1 carbon less. Understanding? 1 carbon less primary amines are formed from acetamide, from the raw material. That is why this reaction is very important students. It is also called as Hofmann degradation of amine. You can also call as Hofmann bromine, because we have used this bromine, so it is also called as Hofmann bromide degradation. This way students, you have to represent the answer in board examination. For 2 marks they may ask. So this way students, you have to represent the answer. If you like my video, please share it, subscribe it. Thank you very much. Have a nice day. God bless you.